Good morning, everyone. Welcome to the business statistics class. And this is our session number 6 in business statistics. So, in the last class, we were discussing about raw data and the data which is distributed in the form of class interval with frequency. So, whenever we talk about class interval with frequency, if a data if a data is represented in the form of class interval with frequency, then whenever we talk about class interval with frequency, whenever we talk about class interval with frequency, any data if it represented in the form of class interval with frequency, then it can be inclusive class interval. It follow either inclusive class interval or it follow discrete class interval, or it follow discrete class interval, or it follow exclusive class interval, or it follow exclusive class interval, or continuous class interval, exclusive class interval, or continuous class interval. So whenever we see a data in the form of whenever we see a data in the form of class interval with frequency, then the data which is represented in the form of class interval with frequency, then the data can be either represented in the form of inclusive class interval. The other name of inclusive class interval is discrete class interval. Then otherwise your data can be in the form of exclusive class interval or the continuous class interval. So inclusive class interval basically means like if this is your class interval and if this is your frequency. So when you talk about inclusive class interval, it's like something like 10 to 19, then 20 to 29, then 30 to 39, then 40 to 49, something like this. This is 7, 8, 5, 3, something like this. So this is the inclusive class interval. Whenever you see a class interval like this is called discrete class interval or the inclusive class interval. Okay, everyone. So whenever we are solving problem, whenever we are trying to solve problem, then make sure your data should not be in the form of discrete class interval. You have to convert the data which is there in the form of discrete class interval into continuous class interval. Your data should be in the form of continuous class interval with continuous frequency. Your data should be in the form of continuous class interval with continuous frequency. That is very important thing. So where when we see the data, this is your lower limit, this is the upper limit, this is the lower limit, this is the upper limit, this is the lower limit, this is the upper limit. If there's a difference between the limit of the first class and the lower limit of second class, then this form data is a discrete class interval data. If there's a difference between the upper limit of the first class interval and the lower limit of the next class interval, then because of the difference, this is called a discrete class interval. And if you see the difference is one. So if the difference is one, so what you need to do, you need to convert the this class limits into class boundary, where we what formula we follow to convert the class limit into class boundary. We apply the formula a lower class boundary. We apply the formula a lower class boundary is equal to lower class limit. Lower class boundary is equal to lower class limit minus d by 2. We apply this formula called lower class boundary is equal to lower class limit minus d by 2. We apply the formula called upper class boundary is equal to upper class boundary is equal to upper class limit plus d by 2. So we apply this formula. So when we are trying to apply this formula, then your class interval will be in the form of 9.5 to 19.5. To subtract zero point 0.5 on the lower limit and add zero point 0.5 on the upper limit, this would be 19.5 to 29.5, 19.5 to 29.5. This would be 29.5 to 39.5. This would be 39.5 to 49.5. So this would be your class interval. So in the case of continuous class interval, we can call this as a lower class boundary or lower class limit. This we called as the upper class boundary or upper class limit. So frequency is 7853. I hope everyone understood this. Anyone, any doubt? Anyone, any doubt? Any question? Anyone? Anyone have question? Anyone have any doubt? Any question? Any doubt? Anyone? So you have to remember one thing, guys. You have to remember that whatever I'm teaching you, everything follow normal distribution curve. So the problems, the discussions, what we are going through, everything follow normal curve, and under normal distribution curve, your data should be represented in the continuous class interval, because normal distribution is a continuous class interval curve, while binomial, Poisson, they are discrete distribution curve. So you have to remember one thing, that whenever we are trying to solve the problem, we have to make sure that we convert the discrete class interval into continuous class interval. This is for the discrete class interval. So for the discrete class interval, for the discrete class interval, lower class boundary is equal to lower class limit minus d by 2. Upper class boundary is upper class limit plus d by 2. While for the continuous class interval, whenever we speak about continuous class interval, lower class boundary is equal to lower class boundary is equal to lower class limit, lower class boundary is equal to lower class limit, and the upper class boundary and the upper class boundary and the upper class boundary is equal to upper class, and the upper class boundary is equal to the upper class limit. So remember this part. So for the continuous class interval, your lower class boundary is equal to lower class limit, and your upper class boundary is equal to upper class limit. So remember this discussion. So you have to understand this part. I hope everyone understands this. Then last class I have discussed you something called class mark. I was discussing something called class mark. What is class mark? Class mark basically means the average of lower class boundary, the average of lower class boundary plus upper class boundary. That is called class mark. So class mark means lower class boundary plus upper class boundary, lower class boundary plus upper class boundary divided by 2. That is called class mark. So this is the formula of class mark. Class mark formula is lower class boundary plus upper class boundary divided by 2. So here if I ask you what is the class mark, normally we represent the class mark with the symbol X. So the class mark here would be 45. So this would be 29, no? 19 plus 8, 28, 29. So 29 means this would be 14.5. This would be 24.5. This would be 34.5. This would be 44.5. This is nothing but 9.5 plus 19.5 divided by 2. This is nothing but this is 19.5 plus 29.5 divided by 2. This is 29.5 plus 39.5 divided by 2. This is 39.5 plus 49.5 divided by 2. Any doubt, anyone? Anyone, any doubt? Any doubt, anyone? Anyone, any doubt? So I'm assuming that because nobody is replying, so I'm assuming that you are understanding everything. So you understood this. What is class boundary? What is class limit? What is the class width? Class width is the difference between upper class boundary minus lower class boundary. That is the class width. So you have understood the difference between each of them. Going further, what I can do, I can discuss this data like this. This as less than class interval with class interval with less than cumulative frequency. We can write the data in the form like this. This is the less than class interval with less than cumulative frequency. There's something called cumulative frequency. So whenever we use less than class interval with less than cumulative frequency, so what you need to do, we always use the upper limit. So you write like this. You'll write less than 19.5. You'll write less than 29.5. You'll write less than 29.5. You'll write less than 39.5. You'll write less than 39.5. You'll write less than 49.5. So we can write the data in the form of less than class interval with less than cumulative frequency. So if you are writing in the form of less than class interval with less than cumulative frequency, then what you will do, use how, so then what you do, write the data in this form. So you'll write like what is less than 19.5. So how many numbers are less than 19.5? That is 7. How many numbers are less than 19.5? 7 numbers are there which are less than 19.5. You can write 7. Then less than 29.5 means how many numbers are less than 29.5? These two numbers are there which are less than 29.5. So less than 29.5 means 7 plus 8. Less than 29.5 means 7 plus 8 means 15. Then if I ask you less than 39.5 means these numbers. So these numbers are less than 39.5. That is 7 plus 8 plus 5. So that is 20 number. So then if I ask you less than 49.5 means all numbers are less than 49.5, means the number 23 numbers. So this is what you need to understand. This is called cumulative frequency. This we call them as a cumulative frequency. Everyone, please write down what is cumulative frequency. Cumulative frequency simply you keep adding them. Cumulative means it's like again you are adjusting them. Keep on adjusting them. Suppose if I have 10 mango and then if I give one mango to the first person, then two mangoes to the second person. So till now I've given three mangoes. Then I give three mangoes again to the third person. So till now I've given six mangoes. So that is what we call as a cumulative frequency. Cumulative frequency, keep on adding them. So whenever we talk about cumulative frequency, we have two kinds of cumulative frequency. We have less than cumulative frequency and we have cumulative frequency. So here we are talking two forms of cumulative frequency. Everyone, please try to understand this. If you have any doubt, please ask me. Anyone, any question you want to ask anyone? So whenever we see the data in the form of class interval, our data can be in the form of discrete class interval or it can be continuous class interval. In case if your data is in the form of discrete class interval, to convert it into form of continuous class interval by doing appropriate adjustments, because we cannot solve the problem based on discrete class interval. So we have to make sure our data should be represented in the form of continuous class interval. Once your data is there in the form of continuous class interval with a normal frequency, what you can do, you can talk about the same data in the form of cumulative frequency. In the form of cumulative, it can be less than cumulative frequency or it can be more than cumulative frequency. Anyone, any doubt, any question? Now the same data can be written in the form of more than class interval with more than cumulative frequency. So whenever we use more than, in more than we use lower limit. In more than, whenever we are using In the case of more than, we always use lower limit. So I can write this as more than 9.5. I can write this as more than 19.5. I can write this as more than, I can write this at the more than 29.5. You can write this more than 29.5. I can write this as more than, I can write this as more than 39.5. So whenever we write the data in the form of more than, in the case of more than, we always use the lower limit. Whenever we write the data in the form of more than, we always use the lower limit. So please understand, whenever we have to write the data in the form of less than, we always use the upper limit. While whenever we have to write the data in the form of more than, we always use the lower limit. So I can write this as more than 9.5, more than 19.5, more than 29.5, more than 39.5. So if I have to write in the form of more than, so how we'll do, we'll start from down. What is the last, how many data are less than 39.5? 3. Okay. Then how many data are more than 29.5? 8 data. Start from down. 8. Then how many data are more than 19.5? So you have last 3 data. How much? 16 data. So you have 16 data like this. Then how many data are more than 9.5? All the data. So that is 3. So the same data we wrote in the form of more than class interval with more than cumulative frequency. See this, everyone. Anyone have any doubt? Ask me. So this I want you to understand. See this, everyone. Clear, everyone? Clear, everyone? Anyone have any doubt? See this question. Everyone see this question. Can anyone tell me the answer for this question? Anyone, can you tell me the answer for this question? See this question. I hope this is visible to all of you. I hope everyone can see this. So now if you observe this, if you observe this question, now in this question, data is written in more than. Data is written in more than. If you observe in this question, the data is written in more than. So because the data is written in more than, so you have to understand, this is the question of more than class interval and more than cumulative frequency. I hope you have to understand this because the data is given in the form of more than. So you have to understand this question is about more than class interval with more than cumulative frequency. I hope you are getting this logic, everyone. Now, when you see this data is in the form of more than class interval with more than cumulative frequency, then understand in case of less than class interval, understand in case of less than class interval with less than cumulative frequency, your data goes like this. Your data become like a pyramid. Your data will increase like this. At the down, you have the maximum data. That is less than. That is how the less than data would be right. But whenever your data is in the form of more than class interval, whenever your data is in the form of more than class interval, if your data is in the form of more than class interval with more than cumulative frequency, if your data is in the form of more than class interval with more than cumulative frequency, your data would be like this. Maximum data at the beginning, and then it will decrease. Okay, that is how it happens. So now if you observe in this question, if you see in this question, if you see in this question, this question is about more than class interval. This question is about this question is about this question is about more than class intervals, more than cumulative frequency, but data is like this. Data is increasing like this. But you need to understand one thing. If you see this question, you need to understand one thing, that this data is actually arranged in opposite order. You can see the number, no? With that you can understand this data is actually in opposite order. So the actual way to represent the data here, the actual way, they're just trying to make you confused. It should be like this: more than 20%, more than 20%, then more than 30%, more than 30%, then more than 40%, more than 40%, then more than 50%, then more than 50%, then more than 60%, then you have more than 60%, and then you have more than 70%, and then you have more than 70%. So then this is cumulative frequency, more than cumulative frequency, that is like this. This is 100, this is 75, this is 60, this is 40, this is 18, this is 7. Okay, so now if you convert this into normal class interval with normal frequency, if you convert this into normal class interval with normal frequency, then if you convert this into normal class interval with normal frequency, you have to understand that whenever your data is written in the form of more than, with more than lower limit is attached. So this is lower limit 20 to 30. Okay, you can see the difference of 10. This is 30 to 40. Then this is 40 to 50. This is 50 to 60. This is 60 to 70. This is 70 to 80. And the normal frequency, if you see the normal frequency at the down it is 7. Okay, at the down it is 7. Then how to find that next 18 minus 7? Then how to find the next 18 minus 7? How to find the next 18 minus 7? You will get 11. Then next 40 minus 18, that I think you will get 22. Then how to find the next 60 minus 40, that is 20. How to find the next 75 minus 60, that is 15. How to find the next 100 minus 75, that is 25. This is the normal frequency. So this is the normal frequency what you will get. So this is the normal frequency what you will get from this problem. So this is the normal frequency what you will get from the problem, that is 25, 15, 20, 22, 11, 7. This is the normal frequency what you will get from the problem. This is the normal class interval. This is the normal class interval. This is the normal frequency. Now, once you get the normal class interval with normal frequency, what once you get the normal class interval with normal frequency, I can find less than class interval. I can find less than class interval with less than cumulative frequency. I can find less than class interval with less than cumulative frequency. So less than class interval if I use, so less than we use upper limit, less than 30, less than 40. With less than we always use upper limit, less than 50, less than 50, then less than 60, then less than 70, less than 80. So less than whenever you use, like, so we always use upper limit. So first one would be 25, next one would be 25 plus 15 means 40, then 50 plus 20, sorry, the 25 plus 15 is 40, then 40 plus 20, that is 60, then 60 plus 22 you will get 82, 82 plus 11 you will get 93, 93 plus 700. The question was that how much got less than 50. The question was how many got less than 50. The answer is 60. The question here was how many got less than 50%. That is answer is 60. So the answer for this problem is 60. That was the problem. Answer for the problem is 60. Clear everyone? Anyone have any doubt? Any question you want to ask? Basit, you can convert the more than directly into less than, but you need lot of practice for that. The recording of the class will be available. In case of any doubt, you can watch the video again. That's why for every class I do recording to make sure that in future you want a reference, you can use those videos for the reference. Because many students face internet issues, so because you are in different parts of India and you may get good internet, not get good internet. So because of all that reason, your class should not get affected. For that reason only I do recording of the class. Fine. And the puja less than is you just add them. You add if you see this, add them. You simply add them. Your work will be done. You add the frequencies, like first one is 25, write 25 like that. Then it is 25 plus 15, add them. 25 plus 15 is 40. Then a 40 plus 20 is 60. Okay, then 60 plus 22 is 82. Then 82 plus 11 is 93. And then 93 plus 7 is 100. I hope this is clear with everyone. Clear everyone? Let's go ahead. See this question. Try this question, everyone. Everyone solve this question. See this question, question number 6. So the following data relate to the income of 90. So incomes are given to you. So income in rupees. So following data, income is given to you in rupees. So income in rupees. Then 1500 to 19999, 1500 to 199. Then 2000 to 2000 to 2499, 2000 to 2499. Okay. Then 2500 to 2999. Okay. So 3000 to 3000 to 3499. Okay. So number of persons, then number of person, number of person, number of person is 13. This is, somebody please switch off your 13. This is 13, 32. This is 13, 32. Then 20, 25, 20, 25. So this is the question. This is the question. You can see this is the normal data. You can see this is normal class interval with normal frequency. They are in the form of discrete class interval. So you can convert that discrete into continuous. That part you can do. Then the question is how many are earning more than 2500. So you have to convert this into more than class interval with more than cumulative frequency. So if you convert this into more than class interval, if you convert this in the form of more than class interval with more than cumulative frequency, if you convert this into more than class interval with more than cumulative frequency, so you write more than 1499.5, then more than 2499.5, then more 2999.5, then more than 3499.5. So if you start with more than, always start with down 25, then 20 plus 25, you will get 45, then 45 plus 32, you will get 77, then 77 plus 13, you will get 90. So the question is how much is, what is the question? Question is how many got more than 2500. So how many are earning more than 2500? Answer is 77. Answer is 77. Clear everyone? Anyone have any doubt? Solve this question, everyone. Here, if you see this question, find the number of observation between 350 to 400. So these values are given. This is more than, this data is more than 200, then 48, then more than 350, then it is 25, then more than 400, then it is 12, and then more than 450, it is 0. This is your data. So this is more than class interval with more than cumulative frequency. So whenever you see more than data, then you have to always remember, with more than we always use the lower limit. So you have to write 200, and you can see, then the next lower limit is 350, then the next lower limit is 400, then next lower limit is 450. So you can see this would be 200 to 350, this would be 200 to 350. Okay, this will be 300 to 400, this will be 400 to 450, this will be 400 to 450, this will be 400 to 450, and this will be 450 to, we don't know the limit, we don't know the limit. So now, if you write them in the normal frequency, how will you write them in the normal frequency? So normal frequency start with down 0, then 12 minus 0, this would be 12. Okay, then this would be 25 minus 12, then this would be 13, and then this would be 48 minus 25, then it would be how much? 23. So they're asking you the number of frequency between 350 to 400. So 350 to 400, this would be 30. The answer is 30. The sum of this should be equal to 48. I hope everyone understood this. Clear? Anyone have any doubt? If you see in this problem, then this problem is about less than class interval with less than cumulative frequency. But what they're asking us the marks more than 30, means they are expecting us to do more than class interval with more than cumulative frequency. So what you can do, you convert that into normal class interval. You have to understand that whenever the data is there in the form of less than class interval with less than cumulative frequency, then in the case of less than class interval, we use always the upper limit. In the case of more than class interval, we always use the lower limit. So here this is the upper limit. So 10 is the upper limit, 20 is the upper limit, 30 is the upper limit, 40 is the upper limit, 50 is the upper limit. So the difference is this 20 to 30, this is 30 to 40, this is 40 to 50. So then if you see the frequency is 100, so total it should come 100. Then start with normal. First is 15, then next one is 38 minus 15, means that you will get 23. Then you will get 23. Then next one is 65 minus 38, 65 minus 38, then it is 27. Then next one is 84 minus 65, then it is 19, then it is 19, then it is 100 minus 84, then it is 16. So this is normal class interval with normal frequency. So this you wrote in the form of normal class interval with normal frequency. Once you write them in the form of normal class interval with normal frequency, then the same thing you can write as more than class interval. Same thing you can write in the form of more than class interval with more than cumulative frequency. So if you write them in the form of more than class interval with more than cumulative frequency, then we always use the lower limit. So you write more than 0, then you write more than 10, then you write more than 20, you write more than 30, you write more than 40. More than cumulative frequency means 15, then 23 plus 15, and then it is 38, then 38 plus 27. So if you are confused, so 15, then 23 plus 15, it is 38, then 38 plus 27, then this would be 65, then 65 plus 19, then this would be 84, and then 84 plus 16, this would be 100. So what is the question? Question is that more than 30, which is more than 30, which is more than 30. More than 30 means 84. So the answer is 84. Okay, okay. Yeah. So 1 minute. So this is like whenever we write more than, I wrote the same data, I wrote the same thing here. I wrote the same thing here. So whenever we write in the form of more than, whenever we write in the form of more than, we start from the down. So 16, then 19 plus 16, then it is 35, then it is 35 plus 27, 35 plus 27, then it would be 262, then 62 plus 83, 62 plus 62 plus 23, then this would be 83. Okay, so this is 16, 16 plus 19, this is 35. Okay, 35 plus 27, so this is 62, 62 plus 23, 62 plus 23, then it is 85, and 85 plus 15, then it is 100. The answer for this would be 35. So whenever we do more than, we'll start from the down. Clear, everyone? Clear, everyone? Anyone have any doubt? Any doubt, anyone? Okay, everyone. If nobody have any doubt, then I like to wind up the class. If nobody have any doubt, then it's time to wind up the class. Thank you, everyone. I'll see you all tomorrow.